Welcome again. Today we are going to start new lesson in algebra, that is arithmetic progression. In previous video, linear equation in two variables and quadratic equation you are giving me, means you can understand very easy way. But today also we are going to start a new lesson, arithmetic progression. Okay, the major outline points of these lessons are sequence, arithmetic progression, nth term of arithmetic progression, and sum of the first nth term of arithmetic progression. Okay, let's clear one by one. Okay, before going to this lesson, it is important to us to understand what is a sequence, then how sequences happen, then what is arithmetic progression. Arithmetic progression and sequence both are related to each other, approximately related to each other. Then how to find nth term of arithmetic progression and how to calculate first nth term of the arithmetic progression. Okay, let's see on the board one by one. First we clear a sequence. Okay, first point, that is a sequence. Okay, look at here. 1, 2, 3, 4. What is this? Serial numbers or in a set of natural numbers. Serial numbers in set of natural numbers. Okay, then 1, 3, 5, 7, ... What is this? Odd numbers in the set of natural numbers. Odd numbers in set of natural numbers. Okay, then 1, 4, 9, 16, 25. What is this? The square of the numbers, serial numbers in the set of natural. Square of serial numbers in the set of natural numbers. Okay, from this you conclude somewhat about a sequence. What is a sequence? From these three examples, are you conclude that what is a sequence? Sequence is a collection of numbers arranged in a definite order according to the some definite rule. Means arrangement of numbers in a definite order according to definite rule, that is a sequence. Are you saying that it is a sequence? No. Because of why? Numbers are not arranged in definite order according to definite rule. Here no rule is applied, no arrangement. Here you can see 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. That means here in this first example, what happens? 1 plus 1, that is 2, 2 plus 1, that is 3, 3 plus 1, that is 4. That means a definite order, addition of one numbers in each term. Number 1, that means plus 1 is added. Here look at this, that is 1 plus 2, that is 3, 3 plus 2, that is 5, 5 plus 2, that is 7. That means here addition of two numbers in previous numbers. That means if previous number is 1, you can add 2, get the answer. What is the answer? You can add two numbers and get the another number. These are odd numbers. Here also you can see the systematic arrangement or collection of number of arrangement. You can see the arrangement in a definite order. Also, in third example, first is the number, okay, first square, that is 1, 1 plus 1, that is 2 square, that is 4. Then 2 plus 1, that is 3, 3 square, that is 9, 3 plus 1, that is 4 square, that is 16. That means here you can see, means in each and every example you can see the arrangement of the numbers in a definite order according to the definite rule. So we can say is that what is the sequence? Sequence is collection of the numbers arranged in a definite order according to the definite rule. We can say that sequence. Okay, is it clear to you? Okay, good. The numbers are denoted by A1, A2. That means in the sequence, the numbers are denoted by A1, A2 up to AN. Okay, A is the first term. A1, A2. A is first term. Okay, A1. A1 is the first term. A1, A2 is equal to second term. Okay, and AN is the nth term. You get the information, and sequence of the numbers is denoted by F1. Sequence is denoted by F1, F2 up to F3 up to Fn. Okay, that means what is the sequence, what are elements in this sequence. In three examples we see the arrangement of the numbers in a definite order according to definite rule, that is called the sequence. In the sequence the elements are denoted by A1, A2 up to AN. How many numbers are there? So many numbers. Of course, less number there. That means A1, A2, A3 up to A10. In another example, A1, A2 up to 100. In another example, up to 700. That means up to AN. That is last number. Nth number. That means A1 is denoted by first term. A2 is second term. Similarly, up to AN, that is the nth number. Okay, and sequence is denoted by F1, F2, F3 up to Fn. Okay, then the terms in the serial order of the sequence are denoted by. That means terms, first term, second terms. Okay, that means also numbers. The numbers are denoted by. We are seeing here, and then terms. What are terms? First term T1, T2, T3. Terms in the serial order. Terms in the serial order are in the sequence are denoted by. Terms in the serial order are denoted by what? T1, T2, T3 up to Tn. That is, T1 means term first, term second up to term nth term. Okay, we can see the examples related with this sequence. Okay, look at here. 9th example, 9th, 15th, 21, 27. Okay, dot. What happens here? Here T1 is equal to 9, T2 is equal to 15, T3 is equal to 21, T4 is equal to 27. Okay, that means we can give first term, this is first term, this is second term, this is fourth term, and third term and fourth term. Another example, 7, 7, 7, 7, dot, dot, dot. Okay, here, which is first term, which is second term, which is third. Similar manner, T1 is equal to 7, T2 also 7, T3 also 7, T4 also 7. Term first is 7, term second is 7, term third is 7, and term fourth is 7. Okay? Suppose another example, minus 2, minus 6, minus 10, minus 14. What happened? First term T1 is minus 2, T2 is minus 6, T3 is minus 10, and T4 is equal to minus 14. Okay? That means sequence, the arrangement of the numbers or collection of the numbers arranged in a definite order according to the definite rule called as a sequence, and elements which are present in the sequence are called, that means first term, second term, third term, fourth term, like this. We can get the examples of these. Okay, are you getting my point? Okay, good. Look at another example. 1, 4, 7, 10, 30. This is one example. Also 6, 12, 18, 24. Okay, and then another example like this. 4, 16, 64. Look at 3 examples. In the sequence, these are sequences. Okay, in this sequence, sequence number 1 and sequence number 2. What happens here? In the sequence number 1 and sequence number 2, look very carefully. Sequence number 1 and sequence number 2, we get the next term is by adding previous term, by adding fixed number to the previous term. This type of a sequence is called a arithmetic progression. Look at here, what I say, I again repeat it. In sequence number 1 and sequence number 2, in sequence number 1, what we say? In sequence number 1, we can say is that we get next term by adding a fixed number into the previous number. This type of sequence is called the arithmetic progression. That means in sequence first term is 1. We add fixed number, that is 3. We get answer is 4. What the answer come 4? In previous number we also add, that is the fixed number 3. We get answer 7. In 7 we also add 3. That means we get answer 10. That means from the sequence we can get information is that the next term we get next term by adding a fixed number into the previous term. This type of a sequence is called arithmetic progression. Okay, now similar way, that is second, a fixed constant. That means in second what happens? First term is 6. We can add 6. We get 12. In 12 fixed number we can add first number 6. In 6 we can add 6. Then we can get 18. 18 plus 6 we can get 24. That means we add a fixed number into the previous. Then we get the next number. Such type of sequence are called arithmetic progressions. Okay. Now here, is this arithmetic progression or not? Please tell me. 100, 70, 40 or 10. Is it arithmetic progression? Yes or no? Yes. This is also arithmetic progression. Because of why? We can add or subtract a particular fixed pattern, particular number or particular arrangement of numbers. That means first number is 100. We can minus 30 from first number, we can get 70. From getting next number, we can do same process. In previous number, we can subtract 30, we can get 40. In previous number, we can get next, that means that is a 10. Like this, that means a fixed number is added or subtracted, multiplied by divided, taking the square, same process. Means a particular, what is the definition I told? Particular, fix in your mind what is a sequence and what is arithmetic progression. When we get the next number by getting, adding, subtracting, dividing, multiplication, whatever may be in arithmetic progression, a fix, adding fixed number, subtracting fixed number, multiplying fixed number, we get next term. Here first term is 100, next term we are subtracting 13, we get next term. And what is next term? In previous number we can subtract fixed number, that means we get next. Okay, that is arithmetic progression. Are you understand? Okay, good. You can hear clear. Remember, from this sequence and arithmetic progression, if the difference between two consecutive numbers, that means difference between two consecutive numbers tn plus 1, tn plus 1 minus tn, that is constant. Okay, the sequence is called arithmetic progression. Here T1 is first term, B is difference between two consecutive numbers. Okay, that means suppose here T1 is equal to A. T2 means what happens? T2 means A plus B. In previous number we can add the difference. What is T3? A plus D plus A plus D plus D. That is what happens? A plus 2D. That is the third terms. Okay, are you clear? First term, that is A, first term T1, A plus difference. That means we add the difference between previous number, that is T2 and T3. In previous number we can add a fixed number, that is first difference, that is A plus 2B. Okay, that means we can clear the arithmetic progression concept. Okay, look at some examples related with this. I write the sequence which is in which it is arithmetic progression or not. Okay, please take. If arithmetic progression, then find what is the common difference. 2, 4, 6, 8, dot dot dot. This is an sequence. Okay, then which here this sequence is an AP, that means arithmetic progression. Yes or no? Yes. And no, why? If in this equation, first term, what is the answer of this equation? First term T1, that is equal to 2. Okay, then T2 is minus T1, that is equal to 4. What is T2 minus T1? That is equal to 4 minus 2. T1 is 2. T2, 4 minus 2, 2. That is, then T3 minus 2, T2. That is 6 minus 2, that is 4. T4 minus T3, that is 8 minus 2, that is 6. You can get the answer here. Look at here, the difference between two consecutive numbers. What is the difference? 2 and 4, difference is 2. 4 and 6, difference is 2. Look at here, 6 and 8, difference is 2. That means difference between two consecutive terms is constant. What is the difference? 2, which is constant. So the given sequence is an arithmetic progression and common difference is 2. Okay, this is clear to you. Okay, we are going to take another example of the 2, 5 by 2, 3, 7 by 2. This sequence is arithmetic progression, yes or no? If yes, then what is the common difference? Find out. Okay, here first term T1 is 2. First term T1 is 2. Then what is T2 minus T1? What is how to calculate difference? We can subtract the number by previous number. What is T2? 5 by 2 minus 2. What is the answer? That is, we are making denominator same. That means 2 multiplied by 2. That means 5 by 4 divided by 2. That is 1 by 2. Half. Okay. That means T2 is equal to half. T3 is minus T2 is equal to 3. Answer is 3. Right? Then what answers? 3 minus 5 by 2. 3 minus 5 by 2, that is equal to 6 minus 5 divided by 2. 3 to the 6 divided by 2, that is 1 by 2. Means also difference is 1 by 2. That is the difference. Here 5 by 2 term, then third minus 5 by 2, difference is same. Here difference is 1 by 2. Look at the example. Difference is 1 by 2. Okay. Another, we go ahead. T4 minus T3. What happens? T4 7 by 2 minus T3. What is T3? 3. 7 minus 6 divided by 2. What is the difference? 1 by 2. I show you each and every term difference is same. So this is an arithmetic progression and common difference is 1 by 2. Okay, here we stop and in next video we continue next point.